I am actually recording this right now, and we're going to do some more practice questions about 7 on exponents. And I'm going to put up a question. I'm going to call on you guys at random, and you're going to give me the answer. I'm not going to say whether you're right or wrong. I'm just going to ask 3 people, and the third person, I'm going to ask them why they got that answer. I'm not going to record us getting questioned. I'm just going to record the explanation of each one when we actually get to it. So let's begin. Feel free to take out a paper if you want, but on these first couple, you could probably do in your head. Check out number 1. Here we go. So look at that. X to the 4th times X to the 7th. And I want to pause it, call on people, and then I'll start recording when I explain it. Thank you so much for explaining that. I want to explain it again right here for the video. Whenever you're multiplying with the same base, when you have X times X, you could add the exponents. So 4 plus 7 is 11. That's why your answer is X to the 11. Good job, all 3 of you that got that right. Moving on to number 2. Go ahead and think about that. I want to pause it and call on you guys. So on this one, we're using the rule that when you have a power to a power, you multiply, right? Not only that, rules 3 and 4 also, and you don't have to remember the number, but whenever you see parentheses with an exponent on the outside, you need to distribute that outside exponent to the inside exponents, and remember that a power to a power, you multiply. So if you actually had more than just an x to the 3rd, like if you had an x to the 3rd, y to the 5th, you would say 4 times 3 and the 4 times 5 on the y if you had a y to the 5th. Right here, it's only one item, x to the 3rd, so you're going to multiply power to a power. 3 times 4 is 12, and that stays as a power, so your answer is x to the 12th. Let's move on. Okay, so I'm not sure if you need to write this down. You could probably still do it in your head. And that is correct. The answer is 8x to the power of 12, just like you all said. So we are going to take, because we have parentheses with an exponent on the outside, you distribute this outside exponent to each and every inside exponent. You see, when you distribute the 3, it's not the number 3 times 2. It's actually the power of 3 that gets distributed to the power of 1 on the 2. So that really does become, when you put it here, it becomes 2 to the 3rd. And when you distribute it here, it becomes x to the 12th. And of course, 2 to the 3rd, like you guys said, is 2 times 2 times 2, which is really 8. So your final answer is 8x to the 12th. And many of us could do this in our head. You don't really need to show your work. Let's try another. 3x to the 0 power. So on this question, the rule that we're applying is anything to the power of 0 equals 1. And the 3 does not have the power of 0 on it. It actually has a power of 1 on it, right? The x is the only thing that has the power of 0. So x to the 0, that actually becomes a 1. And this 3 that you're multiplying, it's still there. So you're going to put 3 times 1. So the final answer is just 3, okay? Now, it would make a big difference if I actually had parentheses around the 3x with the 0 on the outside. Then, yeah, that would become the answer 1, because the whole thing is to the power of 0. The whole thing will equal 1. The rule says anything to the power of 0 equals 1. But in this original question, the only thing that has a power of 0 is x. So x to the 0 is 1, and 3 times 1 is 3. Check this one out. I don't know, you might want to start writing these down now. Who knows? Maybe you could still do it in your head. Go ahead and try it. Maybe talk to a partner about it. Check your answer with a partner. That is the correct answer, 27x to the 6th, z to the 3rd power. Once again, whenever you have parentheses with the exponent on the outside, you distribute, and you could do that first. However, you know, most of the time in mathematics, whenever you have parentheses, it's a good idea to zoom in and try to do any math on the inside. And on the inside, we do have y to the 0. And we know that y to the 0 equals what? 1. Anything to the power of 0 equals 1. So this y to the 0, you could actually put a 1 right here and say 1 times x squared. That would still be x squared. 1 times z, it'd still be z. So putting a times 1 right here wouldn't make a difference. So you could just scratch it out. And now it's a little bit nicer on the inside. It just says 3x squared. Pretend this is not here, z. And now when you distribute that power of 3, it goes on the 3, so you get 3 to the 3rd. It goes on the 2, so you can get x to the 6 because of power to a power you multiply. And 3 right here on the invisible 1, that'll be a z to the 3rd. And of course, 3 to the 3rd, that is 3 times 3 times 3, giving you your final answer, 27 x to the 6th, z to the 3rd, which everybody said. Fantastic. It looks like we're ready for the quiz so far. Let's try another. Here we go. Oh, yeah, that one you should probably write down. Go for it. So on this one, if you're stuck, all you got to do is think about the rules. You could read the rules and see if it applies. Like if you read it right there on the board, it says anything to the power of 0 equals 1. And ask yourself, is there any powers of 0? Yeah, the z to the power of 0. What does that equal? It equals 1. So you could just scratch it out. Because if you did put a y times 1, it would still be y. So you don't even need to put the 1 right there. Any other rules? Anybody? Any other rules? Don't we have parentheses right here with an exponent on the outside? What do we do when we have parentheses with an exponent on the outside? We distribute. That's right. Okay. Now, some of us might be thinking, oh, wait a minute. I have a y right here and a y right there. I could use a canceling rule and cancel them out. Wrong. You can't do that. Not yet. Not yet. Why not? Because the y is inside parentheses. And obviously, when you have parentheses, you need to deal with those parentheses first before anything else, right? So we do have this -3 that we're going to distribute to each and every term. So I'm going to take this -3, put it right there on the 2, put it right there on that -3, put it right there on the y. So I no longer have parentheses, but it will be 2 to the -3 power, x to the +9 power, and y to the -3 power. Are you with me? Okay, so I did that rule. I could already scratch this out because I already rewrote it without the parentheses, okay? So now, what other rules could I apply now? What other rule stands out to you? Anything? The negative exponents. Anything with the negative exponent must be moved to the other side and it'll become positive. So we have 2 items with negative exponents. We have this 2 to the -3, and I'm going to move that up right next to the 5, and I'm going to make that a 2 to the +3 right next to the 5. I'm going to take this y to the -3 and move it up and make it a y to the +3, okay? So they are no longer down here or down here, they are up here. And I had to change the sign. So since they're no longer down there, I'm going to put a line through them. And now what do I have? Well, I have just a single x to the 9th in the denominator. What else could I do? What other rules could I do? Any other rules? Excellent, the canceling out rule. So the canceling out rule is where you have the same thing up on top and on the bottom. So if you have a 5 over 5, that equals 1. 2 over 2, that equals 1. An x over x, that equals 1. And right here, we clearly have x's on top and x's on the bottom. So these 3 x's, right, x times x times x, because of x to the 3rd, those 3 x's completely eliminate with 3 of the 9, which leave you a 6 left over on the bottom. So there are no more x's up on top. All right, that's great. So we've applied several rules already. The distributive rule with the parentheses with the exponent on the outside. We also did the negative exponent rule, moving them up and moving them up and becoming positive. We also did the canceling rule. What other rule could we apply here? Is there any other rule we could apply? Maybe it'll help you if I actually read to you what we have here. We have 2 to the 3rd times 5 times y to the 3rd. What can we do? Yeah, we could combine the y's. Y to the 1 times y to the 3rd, if we think about that. Y to the 1 times y to the 3rd, what do I get? Y to the 4th. So we could rewrite that as y to the 4th and just scratch them out. I know, it's super ugly. And also on top of that, we could take this 2 to the 3rd and actually do it. What's 2 times 2 times 2? 8. So we really have an 8 instead of 2 to the 3rd. So I mean, this is really, really absolutely ugly. So let's write down our answer so far. There's 8 times 5 times y to the 4th. What's 8 times 5? That's 40. Y to the 4th stays up there. On the bottom, what do I have left? X to the 6th. And that is your final answer. Dang, that was fun. Could it get funner than that? Sure it can. Check it out. Here we go. Okay, so obviously, doing this in your head is ridiculous. Don't do that don't do it in your head. Now, there's many roads to the same place. What do I mean by that? Some people see the parentheses and they want to distribute that -2, put it right here, 2 to the -2, x to the -2, y to the 0, z to the +6. You could distribute it, the -2 right there to the 3, -2 right there, get a +4, -2 right there, get a +2. You could do that. But what I always say is if you have parentheses and you could actually do something on the inside, you might as well do something on the inside, right? So what could we do on the inside? So yeah, let's go with that rule of the zero. Anything to the zero power is 1. So y to the 0, you could cancel that out because it becomes 1. And we also have negative exponents on the inside of the parentheses. So I'm going to take this x to the negative 2, and I'm going to move it up right here, right next to that x, and it becomes x to the positive 2. So if you think about these x's right here, that's really a x to the 1 times x to the 2, which becomes x to the 3. Are you with me? Okay. And what about those z's? Well, this z to the negative 3 is going to move down. This z to the negative 1 is going to move up. So I might as well rewrite this because it's looking ugly. I have the 2x to the third z to the 1 over z to the positive 3 after you move it down with the 3 on the bottom. I hope everybody sees that. That z to the negative 3 moved down. It's positive 3 now. Z to the negative 1 moved up. It's z to the positive 1 now. And of course, the x to the negative 2 moved up, and I combined it with that 1. It becomes x to the 3. There it is. Now, we still have the outside exponent of negative 2. So at this point, we could distribute this negative 2 to each and... Oh, no, wait. I'm sorry. We could still cancel. So let's cancel those z's. One z cancels with one of the 3, and you'll have 2 left over. And now we could distribute the outside negative 2 into each and every one, but that would mean that every exponent would be negative, which means we'd have to flip everything. So it's a lot easier that when you have a fraction with an exponent that's negative, to just make it positive and flip it right from the start. So you could take the numerator, move it to the bottom, take the denominator, move it up to the top. That's what I'm going to do. I want to put the 3z squared up on top over the 2 x to the third on the bottom, and it's now a positive 2, not a negative 2. And now let's finally distribute that 2. 2 right there will be 3 squared. 2 right there will be z to the 4th. Maybe I shouldn't write it yet. Let me write it down here. 3 squared, z to the 4th. 2 right there will be 2 squared, and 2 right there will be x to the 6th. So your final answer will be doing the 3 squared, which is 9, and the 2 squared, which is 4, and of course, z to the 4th, x to the 6th. Is that what you got? Excellent. All right. And that's about it, guys. If you understand these, I think you'll be ready for the quiz tomorrow. For the rest of the class, please work on the assignments that you haven't completed, especially that practice quiz.